All right, so today we're doing exponential equations, and I have one that gives me 2 to the x plus 3 power is equal to 4 to the x minus 2 power. So what I want to note first before I do any logarithms is I want to show that 4 is actually 2 squared. 4 is 2 squared. And that's going to match up with this base right here, because 4 can be written as 2 squared, and that has the same base. So what I'm going to do is I'm going to keep the left side the same. Over on the other side, I'm going to change this to 2 squared. And then I'm going to close that up, and I'm going to raise it to the same power, the x minus 2. So the only thing I really did was I changed 4 into 2 squared. And now what I can do is I can mess with the right side of the equation. So notice that I have an exponent right here and right here. And if I have an exponent raised to an exponent, we know that we can multiply those two exponents together. So just like over here, I have m raised to the n power. M is already an exponent, so these two exponents are going to multiply together. So I'm going to get the base of 2, and then I'm going to multiply this 2 by this x minus 2. All right, so now I keep the left side the same, but once again, I'm going to simplify the right side. The base is 2, and the exponent is 2 times x minus 2. I can do the distributive property on this. Multiply everything by a 2. So I'm going to get 2x minus 4 from that 2 times 2. Okay, so now notice that we have the same base. We have the same base right here. But we do have different exponents, right? So what I'm going to do is I'm going to set the exponents equal to each other because we have the same base. So I bring down the exponents and I have x plus 3 is equal to this exponent, 2x minus 4. All right, so at this point, I have an equation where I have an x on the left side, but I also have an x on the right side. So what I'm going to do is I'm going to get all the x's on the left side and all the numbers on the right side. And to do that, I'm going to subtract 3 from both sides. That'll get the numbers to the right side. The 3's cancel right here, and I'm left with x is equal to 2x minus 7. Again, putting those numbers together. The next thing that I'm going to do is I need to get rid of the 2x. And since it's positive, I can subtract it from both sides. So when I subtract them from both sides, the 2x on the right side are going to cancel out, leaving me with negative 7. And then on the other side, I have x minus 2x, which is really just 1 minus 2. That's going to give me a negative 1x. Okay, so I almost have the variable isolated. I just need to get rid of the negative 1 now. So I'm going to divide both sides by the negative 1. All that's going to do is change the sign over here. And instead of getting a negative 7, I'm going to get a positive 7. And these negative 1's cancel out. So my answer is going to be positive 7. So how do I know that this works? Well, I'm going to check my solution on the next slide. So what I'm going to do is I'm going to check it for x equals 7. I'm going to start off with my original equation, that 2 to the x plus 3 power is equal to 4 to the x minus 2 power. And all I'm going to do is let x be 7 and see what happens. So everywhere I see an x, I'm going to replace that with a 7. So I get 2 to the 7 plus 3 power, and over here I get 4 to the 7 minus 2 power. 7 plus 3 is 10. 7 minus 2 is 5. Remember, I can write 4 as 2 squared. I can write 4 as 2 squared. So I don't really need to figure out what 4 to the 5th power is. I just rewrite 4 as 2 squared, and it's still being raised to the 5th power. And on the last step, this 5 and this 2 as exponents are going to multiply by each other to get 2 times 5, which is 10. So I get that true statement. So if I get a true statement from my check, I know that 7 is going to be a solution for this equation. So 7 is going to be the answer for this one. I put that in my solution set because the solution set is going to contain every solution for this equation.